So meta-analysis is what they use in gigantic papers. You know, when they say, "Oh, we reviewed, um, a French study on this subject, a Brazilian study on this subject, um, you know, this American study on this subject, and they were all comparing similar variables, so we kind of combined everything." And so that's what a meta-analysis is. You're looking at a whole bunch of different, sources, looking at similar things, and that are and it can be relatively generalized with when you pay some big-brained statisticians to properly sift through the data. Um, but the bigger thing that they're going to quiz you on is actually right here below. T-test, ANOVA, Chi-square, and Fisher's exact test. The biggest thing to take away from this is how T-test and ANOVA compare means. All right? Chi-square test and Fisher's exact test, which is just like a worse chi-square test. At least you can think about it that way. They don't compare means. They compare proportions or percentages. Okay, well, what does that mean? What is that going to look like on a question? Okay, here we go. So here we have two schools, and we're looking at the average SAT score between two schools, or the distribution of them, looking at the means and stuff. Well, this is 2, so it's going to be a t-test. And if it's more than that, well, then it's called an ANOVA, analysis of variance. So if you've got, 3 of these variables, typically continuous. All right. So let's talk about chi-square tests. Well, here we're not looking at averages. We're comparing the number of people in this categorical, non-continuous kind of position. You're either for something, against something, or neutral on something. Again, here we've got 3 of these variables, so it's not going to use a Fisher's exact test. We're going to use a chi-square test, though you could use a chi-square test on just 2 if you cared to. And below that we have a Fisher's exact test, wherein you have 2 variables and you're comparing, again, not the averages, you're comparing proportions and percentages of things. So on the test, it'll say something like, "Oh, blah blah blah. We were asking kids in the class how they felt about giving drugs to dogs, and a certain amount said this, and a certain amount, said that." You're gonna say, well, 2. I'm probably gonna use a chi-square, though if they want to say Fisher's exact test, sure, but I haven't seen that as much. All right. And then going back, you can also memorize this algorithm, but algorithms suck, and you're going to end up having to memorize so many of them. Why waste your time with another one of them? And then Pearson correlation coefficients, which is visually the easiest thing to look at because you can see how well something correlates depending on, how tightly together the data is strung, and then positive or negative depending on the slope, of course. So if something has a positive correlation, it won't be this because this has a negative slope. Okay. Depending on how tightly strung everything is together, that's going to tell you how strong the correlation is. You can see this is kind of weak. This is kind of strong. Although they both probably have a very similar slope. Okay. So what's R squared? R squared tells you how much of the variance in one variable is due to the variance in another variable. So if we're looking at, let's say I gave you the amount you smoke and its effect on the age of lung cancer diagnosis. First tell me which one of these you think it'll be. Do you think it'll be the positives, neutral, or the negative in terms of the slope? So again, it's pack years and then onset of cancer, lung cancer. Well, in my mind, if you smoke a million pack years, your onset's going to be very low. So it's going to be this thing. Okay. So, and then let's say we have a super high R squared. Let's say it's damn near 1. Well, what does that mean? Well, it says the variance in our data with regards to the amount of pack years can be explained by the variance and how early on you get your lung cancer. So that's R squared. That's R. They always ask one of these as a gimme, but they're going to trip you up with these. And it's more than just understanding, oh, categorical versus numerical, all right? It's understanding that one looks at an average. T-test and ANOVAs look at an average. Chi-square tests don't look at average. They look at proportions, percentages, they look at like numbers. Okay. That's the big thing there.